Hi, this is a video lesson on solving systems of linear equations algebraically. Remember that a system of equations is when you have two or more equations, and in this case, two or more lines. And there are a bunch of different ways to solve those algebraically. So the first one that we're going to talk about today is called the comparison method. And the steps involved are: one, to make sure that both equations are in slope-intercept form, that you have isolated the y in both cases. Then step two is to make the two not y sides, the two sides without y, equal to each other, solve for x, and then replace that x into either one of the two equations and solve for y. Here's an example. So we've got two different linear rules. I know that they're linear because they have an x and a y. Nothing is squared. And my step one was to make sure that both are in slope-intercept form, which means I have to make sure that the y is isolated. So to isolate the y in this case, I divide everything by 2. And in this case, it's to move that 4 to the other side. Basically, to add 4 on the other side, it becomes positive. So these are my two rules. Step 2 is to take the two non-y sides, so 4x minus 7, 5x plus 16, and make them equal to each other. And step 3 is to solve for x. So that means doing the algebra that I'm sure you've done before to solve an equation means grouping all of the variables together, moving them to the same side, and moving all of the constants to the other side. So it doesn't matter which side you move things to, but here I moved things to the left. I ended up with negative x. And I just want x, so if I divide by negative 1, I find that x is equal to negative 23. And step 4 was to take that x value and plug it back into either one of the original equations. And it doesn't matter if this is the one where you already moved the 4 over or not, but I'm going to take that negative 23 and replace it in wherever there's an x, and I'll solve for the y. In this case, it works out to be negative 99. If I had plugged this into the other equation, I would have gotten the same thing. And if you checked it, if you plugged in this x and this y in the x and the y here, and in this one, you should find that the two equations are equal. And that means that that point is the solution, or the point where these two lines intersect. If you want to pause and give that a try, I encourage you to do so. There's a second method as well called the substitution method, and it's very similar, but a little bit different. I'll explain how. So in this method, all you have to do is isolate one variable in one equation. It doesn't have to be y, and it does not have to be in both. So when you isolate that, you'll get an algebraic expression, and what you do is take that entire expression and plug it into the other equation. I'll show you what I mean. So given these two linear equations, what I have to do is pick one variable in one of them and isolate. You can pick x or you can pick y, but you should be strategic. Try to pick a variable that will be the easiest to isolate. Just a little note here, it says that these don't have to be in slope-intercept form for this to work. So if you want to pause and think about which one would be the easiest variable to isolate, I encourage you to do that. In this case, I picked the y in this first equation. And the only reason is because I'll have to only divide by 2, and the other two numbers here, the 6x and the negative 10, are both divisible by 2. I know that it's going to work out a little bit nicer. But you could have chosen any other one, and you would have dealt with some fractions, but it still would have worked. So that's the one that I picked here. And to isolate y then, when I get that by itself, I move the 6x over, I'll divide everything by negative 2. That's what I get as my expression for y. That whole thing there, that 5x plus 3, that's what y is equal to in this case. So what I'm going to do is step 2, I'm going to replace that variable in the other equation. So because y is the one that I isolated, y is the one that I'm going to replace. If I had isolated x, I would have replaced x. And I'm going to replace y with this entire expression for y, 5 plus 3x. So as if there would have been brackets there, because 2 is multiplying y, 2 is going to have to multiply this entire thing. That's the substitute part. I'm substituting it right in, and I'll multiply that out and solve. That whole thing got replaced for y. Now what I need to do is solve an equation just like in the previous method. So I'll expand or distribute the 2. And if you want to pause and try solving this on your own, I encourage you to do that. When I group together all of the like terms, I find that x is equal to 3. And just like in the previous method, what I need to do is plug that into one of the two original equations to figure out the y. If you want to plug it into both, all the better. It's a good way to check your work. And it doesn't matter which one you plug into. The value is x is 3. If you want to pause and check your answer, my answer works out to be positive 14. And it means that the point 3 and 14 is the point where these two lines meet. And that's how you solve using the substitution method and the comparison method.